Hello, I'm Eric Cytrynbaum, and this is the BC COVID-19 Modeling Group's COVID Model Projections for January 19th, 2022. So here's just a reminder of who is producing this report. We are an independent group of academics and affiliated individuals who are working on data analysis and modeling of the COVID-19 pandemic in BC particularly, but drawing data from other jurisdictions when it's necessary to inform those projections. And the goal is both public education and providing additional analysis that might be useful for decision makers. Okay, so overview of the report. As you're probably aware, Omicron is causing rapid growth in healthcare demands in British Columbia. We have a problem with case data now. We're no longer able to track the growth because of limitations in our testing capacity and changes in testing policy. So the case data for those over 70 is hopefully still reliable because that's the group that has been encouraged to keep getting tested. And hospital data is also kind of reliable because conditions for getting admitted to the hospital for COVID symptoms hopefully has been fairly consistent. And so both of these data sets can indicate that the growth rate is slower than it was in December, mid-December, and it's dropped from about 20% per day down to around 10% per day. In the absence of reliable case data, the hospital admissions gives us a good way to track the progress of the pandemic. And it's better than the hospital occupancy data, specifically because there's less of a lag. So the hospital occupancy is basically a summing up of admissions over the last, say, week or two, depending on how long people are staying in the hospital. And that is a more complicated measure to use. And what we would really prefer to have is access to accurate, timely, and consistent daily hospital admissions data that would allow for better projections to understand our healthcare needs coming in the future. And this is sort of an appeal to BC to make that data public in a consistent way. So with the reduced growth rate that I mentioned, the projected peak in hospital demands is now not as high, which is good, but it's delayed, which means this is going to drag on for a little bit longer than it would have otherwise. That is, if we can continue with the current restrictions. And finally, we'll show an analysis that indicates that the projected hospital demands here in BC is looking similar to those experienced in the US. So my first slide here is summarizing a method that Sally Otto has been using to try to estimate our place in the pandemic currently. So the problem that we've run into is that with the growth in numbers of cases, our testing has reached its limits. So the recommendation now is that for people under 65 without health issues, they're now being discouraged from testing so that we can keep the testing capacity open for those over 65. Now, we don't have data broken down by age at 65, but so we're using 70 instead. And so what you can see here is the green data is the number of positive tests for the 70 plus group. And what you see in blue here is the number of positive tests for those under 70. And you can see these are dropping off as we have fewer people under the age of 70 going for tests. And so what Sally's taking advantage of here is the fact that throughout the pandemic, there's been a relatively constant vertical shift between these two curves, which corresponds to a pretty constant scale factor in non-log plot. And so what she's done is she's taken the shape of this curve and matched it here and continued it out beyond. And this is where the correction is happening here. So if you'll notice, if you just look at the growth, so this is on a log scale, and on a log scale, straight lines indicate exponential growth. So through this phase in December with the growth of Omicron, you can see there's roughly a straight line here. And if we continue it out, so this straight line and where it ends up here would be what our projections from December would have looked like, not knowing that things would have slowed down. And so you can see the difference here is it's almost an order of magnitude, maybe a factor of 5 or 8 between where a straight line through here projects out to and where we're at now currently. So what that suggests is that there's a bending down of this curve. Now, Sally's used it here to figure out what the case counts among the under 70s might be, and she's getting close to 12,000 cases per day from that. But it's valuable on its own just to look at this curve, because this curve, which doesn't show a peak like you see here, and so what that indicates is that even though the number of cases among the 70 plus group is slowing down, it's still on the increase, which means it hasn't peaked. And this is the group that is at most risk for hospitalization. So that's two different uses of this 70 plus curve. And so here's a look at that same process, that same method used across the health authorities, Vancouver Coastal, Vancouver Island, Interior, and so on. And you can see in all of them, there is a pretty large split between what the 70 pluses are doing and what we see in the 70 and under data. And so you can see a breakdown of these corrections. Okay, so here we're moving on to Dean's analysis to try and understand what we can expect for hospitalizations. Now, this is a projection based on the case data that was available up until we kind of lost quality data in mid-December, up until around December 21st. And so he's fit the case data here and used what we've known prior to December 21st to try and fit the data going forward. And you can see here in gray are the hospital admissions, so it does well way back here, but it starts to deviate quite significantly recently. Same thing with the hospital occupancy. You can see there's a deviation there, as well as the ICU occupancy, which shows a very large deviation. So because of the failures of the fitting that I described on the previous slide, what Dean has done is he's postulated a transition in the growth rate of Omicron at around December 21st. And so what I mean by that is we had Delta decaying through November up until the point where Omicron appeared. Delta then continued to decay, and Omicron is now present and growing. And so we have a decay rate for Delta, and then added on top of that, we have a growth rate for Omicron. The two together form the green fit through the data. And that holds up until here, at which point Dean postulates that the growth rate for Omicron goes from a 20% per day growth rate down to a 10% as a result of the measures put in place and the resulting change in behavior from the population. And so from that point on, there's a new growth rate, this 10% per day. Now, because he's no longer tracking or interested really in cases, the case counts are not plotted here. They're not really worth comparing to these dots. But you can look over here in the hospitalization, and he's now getting a pretty good fit to the hospital admissions data and the hospital occupancy, as well as the ICU. Now, there's a couple points up here which are probably, we're not sure exactly the date at which the change in protocol for counting admissions happened, but that was sometime in the last little while, the last few days. And so this is probably a result of a change in counting protocol rather than actual genuine change in the growth of hospitalization admissions. So now there's this question of how reliable is the case data that we have right now. So could we imagine that the case data is actually a good reflection of what's going on in BC right now? And what is required is a significant drop in the case rate. So in other words, we have to go from 20%, which is consistent with the data pre-December 21st, to all the way down to low enough that you would get a turnaround in the data. Now, the question is, okay, maybe that's possible. Maybe the measures put in place actually accomplish that. What we can do is then try to fit the hospital data. And when you go through that process, you can see that it's impossible with this now decreasing case count to have a realistic fit to the admissions data. And that's even before we had the recent change in the protocol for counting hospital admissions. And so you can see that we're unable to fit the hospitalization admissions or occupancy data using a model in which the case counts turn around as dramatically as we've seen in the now not so useful case counts. Okay, so long-term projection, if we use this reduced transmission rate for Omicron, and we want to project forward to see what does that mean for hospital admissions, what it does is it projects forward that there's going to be increasing demand on hospitals up to quite a high level. So you can see here, let's see, there's the peak. So we're at about, that's 1,000, 2, 3, 4, 5,000. So that's a hospital occupancy of about 5,000 with a peak admissions per day in the range of 500, which is remarkably high. And that peak is coming sometime in mid-February. So that's a little slower than would have been the case if we were in that 20% per day growth regime that we saw in December. All right, so on this slide, we have some analysis from the US. This is a state-by-state analysis that Dean's carried out. And so the idea would be here is to try and understand where British Columbia is in comparison to the US states. And if as you'll look and see through all these slides, they tend to be slightly too well ahead of us in their pandemic progression right now with Omicron. Okay, so what are we seeing here? So here is the daily Omicron hospital admissions per 100,000. And it's roughly in groups by geographic region. Obviously, BC has been thrown in there. It's not a northeastern state. So BC is present in all these graphs as a thick black curve down at the bottom. And they've all been normalized so that they go through 2 hospitalization admissions per 100,000 per day at t = 0. So, everybody's on a slightly different time course, but similar trajectory, say. And so we realign them all and we get them all crossing through that point. And that point was chosen because that's roughly where British Columbia is currently. And so when we compare to see where does the peak come out for all of these states, you can see that we are really early on in that progression throughout. And you'll notice that no matter where we look, and so I'll show another slide here with another 6 groups of states here. You can see that many of them have already peaked in time, but none of them had peaked by T0. In fact, I don't know if there's any that have peaked before day 10 in that that shifted count. And so what this suggests is that BC is really not very far along the curve towards the peak. We still have at least a week or 2 or maybe more before we're going to see peak hospital admissions. Now, one caveat here is that vaccination in BC is quite good, and that's sort of reputed to be not quite as good in the United States, but that's a state-by-state issue. And for example, in the Northeast, it's not so dissimilar from what we have going on here. So on this slide, I'm going to revisit a model from Sally Otto, which was in our previous, the last couple reports. The updates here are in red, and so Sally has modified it to account for the more recent vaccination and boosters in the model. And she's also dealing with severity in a slightly different way. So severity, she's going to vary that across a range of reasonable quantities. Now, what we're treating as kind of we're not treating them as the parameters, but we're treating these 2 numbers from the literature, 76 and 33%. Those are estimates from 2 different studies. And if you look at the details of how these studies were carried out, who was counted as a hospitalization case and so on, what we see is this is, in a sense, seems to be like a reasonable upper bound for what we might be experiencing in Canada. And this one seems more like a lower bound. So we'd expect to be somewhere in that range. And so let's take a look at the analysis and see what predicts for hospitalizations. So what you're seeing here, and I think this is similar to previous slide, up until December 1st, we trust the case data, and so Sally is fitting the model to that case data here. What you see in colors is each of the the areas under these correspond to how many people of each age category. So the purple here is the 0 to 10s, and then that rises all the way up to the 90 plus in the top sliver up there. And so that's total infections. The number of cases is going to fall well below that because we only catch roughly a quarter of infections with the cases. And that's up until here around December 21st. After that, the data is just in there to illustrate where the data has fallen away. And the projection forward of that fit takes you up here. Now, if we trust the 70 plus data, instead of looking at all the cases after the December 21st, now we're just looking, all of this data here is just the 70 plus. And you'll notice the scale, the vertical scale here, 8,000 is quite a bit lower than what it is here, 150,000. That's because the data here, the blue, and green, light and dark blue and green, that corresponds to just this thin layer at the top. So we take out the yellow down to purple, all of this gets removed, and this is if you collapse that down to the axis, this is what's left. So now when you look at the 70 plus case data, you can see that it fits quite well even past December 21st, but then it seems to fall away here, doing something slightly different. So there seems to be some decrease, maybe at some point, or maybe the whole curve is actually just a little bit lower. So Sally has proposed two possible explanations for that. One is that the older individuals have restricted their contacts more than others in the population. And the other possibility is that Omicron growth rate has slowed overall for everybody. And that's actually, this second hypothesis is actually consistent with what Dean was finding in his analysis that I covered earlier. So this is what happens when you modify the model using this reduced contact rate in the 70 plus group. You can see that instead of fitting through this data here and then falling away later, you see there's still deviation from the data, but it seems to catch a little bit more of it. So it doesn't really capture this slower region, or something about it is a little bit different. So here in the second hypothesis, when Sally reduces the growth rate of Omicron overall for everybody, what we see now is, so here's again the fit to the case counts, and then what happens in the 70 plus group is over here, and you can see overall this has a better fit. Now there's some deviation from it in places, but overall this is a much better fit. And what that suggests is that a reduction of the growth rate is more in keeping with the data than a reduction in the contacts for just the 70 plus. And the numbers are actually fairly similar to what Dean found, which is that a reduction from 20% down to 12% on December 24th gives us this improved fit. And that was compared to Dean's 20% down to 10% on December 21st. So ballpark, these are a very similar type of modification to the model. So we think this is most likely what's happened, that the measures put in place in late December have led to a fairly dramatic decrease in the growth rate. So what are the implications of a drop in the growth rate from 20% down to 12%? So let's just flip back to the original projections before this decrease. So you can see here that the total number of cases per day at the peak are over 150,000 here, and that peak is supposed to have happened before January 15th. And now if we look at the projection with the 12% growth rate, you can see that that peak is now down to almost half as high, and the time of that peak has been delayed maybe almost a week or so. And so there's a spreading out of the infection, which is how we manage to bring the risk to our hospitals down lower as a result. So let's take a look at what this means in terms of hospitalizations. So all of these curves here well, both of these sets. This is in scenario 1 where the context for the 70 plus has been reduced, and this is where the reduced transmission rate for Omicron in general has been implemented. And so what you see if you assume a range of severities, so the severity right down at the bottom here is 0.1 of, so Omicron is 1/10 as severe as Delta was, and as measured in terms of the risk of hospitalization per case. So this goes up to 0.2, 0.3, 0.4, all the way up till the same severity, or actually this one is all the way up to 90% as severe. And the darker ones, the green one here and the dark green here, those correspond to the 33% from that one UK study and 76% from the other. So we expect to be somewhere in between these two curves. And when Sally runs the model and puts our hospitalization data over top of it, you can see that the data lines up with roughly with a curve below the lower limit of what we would expect to see in Canada. And when looking at the second hypothesis, that is a reduced growth rate for Omicron, you can see that it's at the lower end of the sort of expected range, but it's still within it. And so that's supporting the idea that the difference that we've seen in the last few weeks is due to a reduced transmission rate or reduced growth of Omicron. Okay, next slide here is just giving you a look into what's going on with vaccination and boosters. We haven't had a huge amount of progress with the first and second dose vaccinations, but in the last week, there's been about a 6.2% increase in the number or the percentage of people across the province who have had their boosters. And you can see that in the blue curves here, which are making their way around the donut. So the next slide is just summarizing the effect that vaccination has had in our population. So here on this plot on this side, you see the relative risk of infection of an unvaccinated individual compared to a vaccinated individual. And you can see that back in September, before everybody who was immunized started having less protection against Omicron, that we had about almost a factor of 9 difference in our risk of getting infected. So vaccinated individuals were 9 times less likely to be infected than unvaccinated individuals. Now, with the onset of Omicron, that dropped dramatically down to around 1.5 or something like that. So more vulnerable to infection. However, severity is a different story. So this plot over here shows risk of hospitalization. And you can see there's still a drop in the risk of hospitalization, and that sort of related to the fact that there's a much higher risk now, or relative risk is closer to equal for vaccinated and unvaccinated. But vaccinated individuals still have about a factor of 10 protection. So a vaccinated individual is 1/10 as likely to end up in the hospital as compared to an unvaccinated individual. So let me just go over as a final slide the key messages from the report. So on the state of the Omicron wave in BC, so we have this observation that in the 70 and over age category, we're continuing to see rise in cases across the province. We think that this is an accurate measure because individuals over the age of 70 were generally encouraged or not discouraged from getting testing when we hit our testing capacity. This is an important observation because this is a group that will be disproportionately determining the load on hospitals as we go through the peak. So at the same time, we see a drop in cases in the under 70 group, but we're concluding here that this is likely due to a change in testing policies rather than any reflection of actual trends. So Dean and Sally's models, using various methods, both indicate that we have seen a decrease from a 20% per day growth rate in mid-December down to what seems to be around a 10% growth rate now after the measures had their effect and people's behavior started to change. So one of the benefits of that is that the hospitalization curve will be bent down, not going to reach as high a peak. However, there will be a delay in reaching that peak. So if our current behavior continues the way it is, infections are expected to peak in late January, early February, with hospital occupancy peaking later in February. Okay, and addressing data gaps. So it would be really helpful to fill these data gaps for the sake of reducing the uncertainty that we're seeing in our modeling. For example, rapid antigen test results, if they're made public, we could use those as part of our gauging of the trends, infection trends in BC, and that's currently not available. We also have access to wastewater data that's been made public, but the flow of that data, so to speak, has been stop and start. So we had a long break from it, and we're missing some days. It's also all measured in concentration, which means that when we have a rainfall or a snowfall and that snow melts, that we get a sort of a washing out, and the signal is a little bit hard to interpret from just concentration alone. And accurate and timely and consistent daily hospital admissions data would allow for better projections of healthcare demands in the future. Hospital occupancy is not as good because it involves a more serious lag, and it's also complicated by cases that stay in, individuals who stay in the hospital for long periods of time, and that throws off some of the data. So hospital admission data would be ideal, and we haven't always had easy access to that data. So that is our report for January 19th. I hope you all stay safe until our next report.